Okay, can you guys all hear me? All right. Thanks for being here. I hope you're all having a great conference. I'm here to talk about accelerating batch processing workloads on Apache Spark on Amazon EMR with Spark RAPIDS. So in this talk, I'll go over what is the RAPIDS accelerator from Apache Spark. We'll talk about how it works, the benefits that it brings, and talk about some next steps. So we all know that enterprises benefit greatly from the data that they collect. Critical and impactful workloads for enterprise data include data preparation for ML, reporting, analytics, operations, and more. And we want these data sets to be processed as quickly as possible. We know that data sets collected by enterprises are growing. In fact, an IDC report says that by 2026, 221 zettabytes of data will be generated in that year alone. What is a zettabyte? A zettabyte is 1,000 exabytes or 1,000,000 petabytes. And that's up from the 125 or so zettabytes generated this year. And about 80% of that data is unstructured data. It's the kind of data that is often processed on large-scale distributed systems. We want to make sure that we get the value from all of that data as much as we can. So we want to be able to verify, transform, and prepare that data for processing. But how can we do that for such large data sets? One way of doing this is to expand the compute infrastructure, because we know that Moore's law has tapered off. So we can add more nodes to our cluster, but that increased costs. The other way we can do it is to downsample the data, which would allow us to process within the same amount of compute that we have, but of course that reduces the data fidelity. So we propose another option. So one of the most popular data processing engines is Apache Spark. And NVIDIA has taken the time to work on accelerating Apache Spark batch processing with GPUs. Apache Spark 3 enabled some key innovations that allowed us to do this. The first is resource-aware scheduling. In Apache Spark 3, Spark is aware of accelerators, CPUs, FPGAs, and can schedule tasks on these different types of resources. The other thing that Apache Spark 3 brought was the ability to add plugins. So you can create a jar and create your own plugin for Apache Spark. And finally, Apache Spark 3 has columnar data processing, which is very well suited to parallel operations and accelerations on GPUs. So the RAPIDS accelerator for Apache Spark is a Java plugin that automatically accelerates operations on GPUs. From a user perspective, no code change is required. They only need to configure their application with the plugin so that operations that are GPU accelerated will use the GPU. The plugin works on data frame operations and is integrated into Spark distributions like Amazon EMR, AWS Databricks, open source Apache Spark, and other cloud provided Spark distributions. So how does this actually work? So here's an example of a SQL or the equivalent data frame operation. What Spark will do first is it will take these operations, it will convert them into a logical plan, it'll optimize the logical plan, and then convert that to a physical plan. What we're doing is capturing that physical plan and replacing the operations or execs that would normally run on the CPU and have them run on the GPU. So from a user perspective, they don't have to make any code change. And the Spark RAPIDS accelerator jar takes care of running on the GPU. And here's an example of a GPU physical plan. I know it's a little bit small, but the CPU exec operations are replaced with the equivalent GPU operations. So to take a closer look at what's happening inside the physical plan, let's start at the top. So the user still writes their Spark data frame or SQL API application running on top of the Spark core. They do need to make a config change to call the Rapid Spark plugin. The plugin is available for download on Maven Central or already integrated into Amazon EMR. If in the physical plan an operation can be GPU accelerated, we call out to Rapid Spark. We make a call through JNI to an open source set of libraries called RAPIDS. RAPIDS is a set of open source libraries for data operations on CUDA on GPUs. So we leverage the CUDA data frame library, the QIO library for reading and writing, Parquet, ORC, Avro, and other data types, and the RAPIDS memory manager, and we call out to CUDA. So from a user perspective, they don't need to know or understand CUDA or worry about that. This is all taken care of in these libraries. If an operation and data type hasn't yet been GPU accelerated, we'll fall back to the CPU. And then we'll go back to the GPU for the next operation that can be run on the GPU. I want to emphasize that no code change is required. So here's an example of a benchmark query that runs on the CPU. The exact same query runs on the GPU. We just need to set the class path to add the Rapid Spark jar, and it's the same SQL and data frame code. It's compatible with PySpark, Spark R, and SQL, other data frame-based APIs, and we'll fall back to the CPU for any unsupported operations. So in Spark 3, GPU resources are visible in the Spark UI. If you select the additional metrics, you'll be able to see and check off resources. You'll be able to see the available resources, and in this example, you can see the GPUs and the active tasks running on the GPU. This is another example of a DAG where the CPU operations are replaced by GPU operations, and we also have the metrics published from the GPU. So you can see how the operation is running on the GPU. All the same metrics are there. And if you do an explain on your plan, you can see the CPU execs have been replaced by their equivalent GPU execs. So that's a little bit about how it works, but how does it perform? To measure how this performs, we run a benchmark. We call it the NVIDIA Decision Support Benchmark. This is our adaptation of the TPC-DS benchmark, which is an industry standard benchmark of about 100 queries that's often used by Spark users or developers of Spark to benchmark how their environment runs. We try to stay as faithful to the original benchmark as possible. We make very minor changes for Spark syntax, single quotes and double quotes, and some date add operations. But we publish the benchmark in our open source GitHub repository, and anybody is welcome to replicate the benchmark and use it themselves. And how do we set up the benchmark? So we set up the benchmark with a CPU cluster on Amazon EMR with a set of drivers and workers running the M7G instance type. So 1 driver, 8 workers. And we have a 3 terabyte CSV data set that's converted to Parquet, snappy compressed, stored on an S3 bucket. For the GPU cluster, the driver node is the same. And instead of the M7G worker, we're using the G5G, which is an instance type, or I'm sorry, yes, we're using a G5, which is an instance type that has a single A10 GPU. And we chose this instance type, the G5 8X large, to match the number of CPU cores and memory in the CPU instance type. We would have chosen the G5G, but it's not available in EMR. But the G5, the Graviton instance is a great, cost-effective, and efficient CPU instance to benchmark against. So how did we set up the GPU cluster? There's 3 steps. The first is to enable the RAPIDS Spark plugin on your Amazon EMR cluster. The second is to configure Yarn to be aware of the GPU. So that's a 2-line shell script to configure C groups. And the third is to configure Spark to use RAPIDS. Very straightforward steps available online in the Amazon EMR documentation. And there's a link to it here. So when we run the benchmark and we compare the performance of the GPU nodes to the CPU nodes, we see that for the top 25 queries, there's a 2 to 5x speed up on the GPU instances. And not only is there a speed up, but on average, you're saving 30% when running on the GPU. So we're able to deliver a significant cost savings and speed up by doing batch processing on GPUs. So where does the GPU really shine? The GPU is great for data sets that have high cardinality data, where we're doing complex joins, aggregations, or sorts. The GPU is great at windowing operations and complex processing, transcoding data formats, or encoding Parquet and ORC. The GPU is not as good when there are a lot of UDFs in the operations. And we do not accelerate data set or RDD operations. So then, how do you actually know which of your Spark jobs to run on the GPU? You may have thousands of Spark jobs, and if you want to try, which ones do you try with? We have what we call a qualification tool. And what we do with this qualification tool is we can analyze your existing Spark 2 or Spark 3 event logs and use that to determine which of the jobs might be best accelerated on the GPU, how much acceleration you might get, and what your cost savings might be in that environment. So what that looks like is when the tool runs, there is some output that shows jobs that may be strongly recommended, recommended, or not recommended. And we provide a summary with an estimated speed up and savings. We try to be conservative in the summary. We are going to say that it is an estimate, but this is a good place to get started when trying to accelerate your Spark jobs. The tool to do your qualification analysis is a simple Python package. You can run this on your laptop or workstation as long as you have access to your Spark cluster. You can pip install the Spark Rapids user tools package. So the steps to run the qualification tool are install the package, make sure that you have the AWS CLI installed with access to the S3 buckets where your Spark event logs are stored, and that your Amazon EMR cluster is available. It doesn't need to be running, but just needs to be available. And there is a one-line command to be able to run the qualification tool. So we've been working on this project for a few years now, and we've had customers who've had success with this deployment. with Rapid Spark. A couple of examples. We have deployed this with a large retailer that has a e-commerce site and wanted to re-rank content on that site on a regular basis without increasing their cost. They wanted to increase the volume of data that they were running through their ML algorithm. So they were able to deploy Rapid Spark and reduce their cost significantly. We have deployed this with a large telco, where the telco has an ETL pipeline feeding an ML pipeline and wanted to be able to run their jobs cost effectively in a Databricks environment. And we're able to deploy Rapid Spark in that Databricks environment to reduce their overall costs. And we also worked with an ad tech company that wanted to stay within the footprint they had because of their budget, but their data volumes were continuing to grow. They had developers who kept saying, we want to put more and more ETL jobs into this cluster, and their IT folks kept saying, no, you're kind of constrained here, this is what we have. So they were able to deploy Rapid Spark under very stringent conditions. They had speed up and acceleration goals of 5x or more, and see many of their jobs accelerated within their existing footprint. So with Rapid Spark and NVIDIA GPUs, you can reduce costs of your existing ETL jobs. You can accelerate the execution of your existing jobs, and you don't have to downsample or reduce the fidelity of your data. You can expect the data volumes to continue to grow and keep up with that data volume growth with GPUs without expanding your compute. So I want to add to that we do stand behind this with a program called NVIDIA AI Enterprise. NVIDIA AI Enterprise helps provide support for organizations to deploy Rapid Spark, to walk them through the different tuning and profiling of their jobs, qualification of their jobs. For NVIDIA AI Enterprise customers, we provide security patches, we provide critical bug fixes, we'll work directly with you if there are any issues in your environment. And we do provide an SLA response time for that professional services support. The support is available at our NVIDIA.com AI Enterprise Suite site or on the Amazon Marketplace. So for more information and next steps, there is documentation available on the docs.nvidia.com site. If you go to docs.nvidia.com/SparkRapids. As I mentioned, we are an open source project. If you would like to engage with the open source community, we've got a lot of great contributors there and active discussion. We're available on github.com/NVIDIA/SparkRapids. And there's a link to the user tools download from the PyPy site and information about the NVIDIA AI Enterprise. I think I have about a minute for questions, so if anybody's got questions, I'm happy to take that.